Start in like 2 minutes. Just give everybody time to filter in here. Bless you, Jess. Welcome, everyone. Welcome. Happy Climate Action Day to you all. Thank you all for being here. We're going to get started in just a second. I hope your first ever Climate Action Day is going excellent and you guys have a lot of fun energy and fun things planned. Before we get officially started, just a few things. Number one, please make sure you're muted for our presenters. We are going to have a section at the end for you to ask questions. So as they're speaking, start formulating the questions that you're curious about. As we get towards the end, we're going to hear from a couple of different people in a couple of different roles. So there is a lot of exciting information to share. So hopefully you'll have a lot of interesting questions for them when we get to the Q&A portion, which we'll have at the end. If we don't get to your question today, there'll be a follow-up email with frequently asked questions that will be answered for you that you can reference in the future, as well as the slideshows that you guys see today and a video of the recording. So that is also something you should know. We're recording this session for other schools to be able to view at their own pace, at their own time, if they couldn't make it with us here today. So with that, welcome. Thank you all for being here. My name is Kaylin Fox. I'm the Education and Training Manager here at the Office of Energy and Sustainability. And we're really excited to have our second of 2 Climate Action Day energy-centered clean energy career talks. So welcome. Thank you for being here. And I'm going to kick it to Jess.
Thank you, Kaylin. Hi, everyone. My name is Jess Brossman, and I'm an engineer at the National Renewable Energy Laboratory, or NREL. It's located in Colorado. And I'm also an organizer for our ST Pathways program, which is a STEM career talk for all of you guys. So thank you for being here today. And I'd really like to introduce our speaker, Andrew.
Hi, everyone. Let me share my screen. All right. Well, I'm really excited to be here today for your Climate Action Days. We're going to be talking about different career options in energy efficient buildings. So a little bit about me, Andrew Nasrallah. I'm living in Las Vegas, Nevada. I'm currently the Director of Technical Design for the Friedmutter Design Group. And I'm currently working on my licensure. So I'm going to talk a little bit about what I do and how it relates to all the other different career options that, oh no. That was weird. Give me a moment. Trying again, sorry. All right, we're back in business. Kicked me out from my account. Okay, so I'm in Las Vegas. So my company works on really large international hospitality and casino projects. The Cosmopolitan was one of ours. We're working all over the world. It's really interesting. And when we get into these gigantic buildings, it's really important for us to pay a lot of attention into how we use our energy. And sometimes it might seem like a lot of the decisions that are made are really wasteful, but in fact, there's ways we can do it to be smart about our energy usage. And as such, our relationship to high performance buildings is really complex and holistic, and it starts from the very beginning, from when the idea is conceived of building a casino or building a restaurant. We need to be prepared for all the eventualities and how we use our energy to the best of its ability. Now, why do we care about energy efficient buildings? Well, we use buildings all the time. We can't get away from that. And it's really important to know that residences and commercial buildings use 40% of the country's energy. And we know that energy use is a leading cause of climate change. So by reducing our reliance on energy in our buildings, we can reduce our impact on climate change. Now, buildings are kind of complex, and there's two ways that we can reduce our energy usage. We can reduce the use of the building itself, or we can generate energy on through solar panels and the like. And I think Rory's going to talk a little bit about that a little bit later, and I'm going to be talking more about how we can have some crews that might reduce the usage of a building itself. Buildings have three major parts. You've got your building envelope, the things that keep the outside out and the inside in. That'll be your roof, your walls, your doors and windows, and your floor. Then you've got your foundation that supports the building and keeps it from falling down. And then you've got your internal support systems to support the functionality of the building. So you've got your HVAC systems, which is your air conditioning. And then you've got your electrical systems, your lighting, which is most of what I think we think about whenever we consider energy. And then we've got your plumbing systems. And so it ends up being quite complex with all these different parts. And in fact, each one plays a significant role in how much energy a building uses. And so when we think about all these different parts and how each one can have a different impact, we can start to imagine how there's lots of different career opportunities for us to get involved with and to try to reduce our energy use in buildings. So let's talk a little bit more about what energy efficiency is and how we test it. So energy efficiency is the amount of energy produced or the work done as a percentage of the energy used. So how much output we get from our input. So if we put, 10 pieces of energy in, how much heat energy for an air conditioning equipment out do we get? So that's how we measure it. And then whenever we try to evaluate what is better than what system is better than another system, we try to determine what uses less energy to accomplish a task. So all refrigerators keep food cool. Okay, so even old ones from the 50s. But now our Energy Star rated refrigerators use less electricity. So maybe you've seen a little tag on your refrigerator or on another appliance you might have. It says Energy Star on it. That's the government's way of letting us know that this piece of equipment is approved to a certain standard of energy efficiency. So we like to select our appliances based on their energy efficiency. And we do this for two reasons. First is for the climate, but the second reason is it lowers our own individual energy bills. So it costs us money to waste energy. So it makes a lot of sense to simply reduce our energy, both for personal reasons and for the reasons of the world. So that's the energy use. But then there's other ways that energy is spent. So building materials themselves use a lot of energy. And we can talk about this in a life cycle assessment framework. So we want to choose building materials that use less energy per square foot used. So some major elements of that would be like a roofing material or a material that doesn't have to be transported as far. So in Las Vegas, for example, we don't really have very many trees. So all of our wood comes from, the Northwest, and it has to be put on trucks and hauled hundreds and hundreds of miles. And that takes a lot of energy. And so, we might not think about that as a direct energy use, but it does add up over time. So where do I fall into this? So as an architect, I am hired directly by the owner, and then we hire consultants and engineers to help design the building. Then once the building is designed, we hire the general contractors hired by the owner, and then they hire a whole giant team of people to build the structure. So when we're talking about the number of people involved in even a house, it could be 150, 200 people that all touch that building at some point during the process. And on the huge ones, it can be in the thousands. There's lots of opportunities. And so as the architect, I kind of get to touch all of these different roles slightly. And I kind of work as the coach. I kind of help everybody find their way. How do we get into these different careers? Well, there's 5 main routes, right? So we could go to a community college or a junior college where we get an associate's degree, and we start our path that way. There's trade colleges, which teach you how to do a specific task. So you might be go to an electrician trade college or a plumbing trade college. And then there's union apprenticeships. So this would be a path where you get a job, so you get paid immediately, but you're also being trained under a licensed professional. And then there's the traditional 4-year university route, which I think we're most familiar with. But it's important to know that there's no wrong route here, and they all have major pros to them. And the goal of this is to get you into the career that is best suited for you. And were I to go my route again, I probably might have gone a different way. My undergraduate degree, which was from a 4-year university, was in biochemistry. And now I'm an architect. And so you never really know where it's going to take you. But the important thing is that we just keep moving forward and finding our way as to what makes you the happiest. So let's talk about some of these different career options that we can get into. So one that I work with a lot would be a construction manager. So this would be the type of job you might want if you are really organized. So a construction manager is responsible for making sure that there's the right people on a construction site, that the material's there at the right time, that everything is going as planned, and they're the point of contact for the owner and the architect. And so these are really important roles, and the pay is high. So typically these people would go to a 4-year university, and then you'll get experience on the job, usually under someone who's done the job for a while. So this would be someone who, if you like working outdoors, you like building things, but you're really organized, that's the key thing. You might look into being a construction manager. So construction managers are great, but energy efficiency sales representatives are really important too. And in fact, there's lots of sales representative jobs that have a major role in energy efficiency. And this would be for someone who likes working with people and teaching about new technologies. So in my role, I can't know everything. There's too many parts and pieces of this puzzle of a building that I can't know. So I rely on knowledgeable sales representatives to tell me what the new technologies are, and then I can suggest that the owner employ them. So as an energy efficiency sales rep, you're going to be working with architects and owners, and you're going to be telling them about these new technologies that you're excited about, because we want everyone to be excited about what they do. It makes life a lot more fun. So you're going to be talking about different manufacturing equipment and products, and you're going to be the link between the researchers and the actual application of it. Typically, you're only going to need a high school diploma, and you'll get hired on with one of these companies directly. And these can be like solar companies is the one that comes to mind the first. So they're really important roles, and can be highly lucrative. You can make a lot of money doing this. So engineers are people that I probably work with the most on the design side. So if this is going to be a role where you're going to get a bachelor's degree, and then you'll work towards licensure, similar to the architecture route. So an engineer is going to be someone who's really good at solving puzzles and trying to figure things out. So you're going to run into problems, and you're going to need to find workarounds with your vast knowledge of how to apply math and science to design something new. and you're going to work on a specific project. So there's different types of engineers. You've got plumbing engineers, mechanical engineers, acoustical engineers. There's lots of different realms. You can kind of pick and choose what you're interested in. And then there's also engineers who work on solar panels and do specifically energy efficient things. But there's in each of these are going to be the designers who are going to be applying their knowledge of energy efficiency to a specific project. So again, all of these jobs are highly lucrative. You've got lots of different options for them. And it just depends on what fits you best. So kind of take an evaluation on what skills you have and when we're talking about these. So a draftsperson. So I started off as a draftsperson when I was moving into the construction field. And when these are for people who like to draw and work with computers. So you're going to be using the guidance of either an engineer, an architect, or it can be a wide range of people, and you're going to be, or scientists really, and you're going to be applying that knowledge and you're going to be drawing those thoughts. Usually this is going to be a certificate or associate's degree. I know a bunch of high schools are implementing CAD programs where you can get a certification right out of high school. But really, you don't need a lot of educational experience beyond an associate's degree to become a CAD technician. This is a fun job that gets you into the design field. So computer numeric control operators. This one's really fun and upcoming field. So now that we're automating many of our systems. So when you've maybe heard of 3D printing. Well, this is very similar. So we have these giant machines that create the parts that go on buildings. So these are going to be detailed oriented people who like working with power tools, and some of the facilities are really fantastic. They're depending on what they're building, they can be humongous. I know a lot of the prefabricated structures are going the CNC route. We have several facilities in town that do this type of work, and basically you're going to be interpreting drawings and blueprints, and then you're going to be programming these big machines, and so the machines do all the work for you. It's really, really fantastic. Typically, you're going to need your high school diploma, and then you're going to get training on the equipment whenever you get the job. So in this case, an associate's degree is often desirable, and remember, we get our associate's degree from usually a community college or a junior college, and this is a really fun field, and often it's applied for aerospace, but now that the building industry is moving toward a more computer system, the CNC field is growing significantly. So then there's advanced manufacturing technicians. So the last one was working in a factory, and this one's kind of a factory job as well. So this is someone who works on big machines that build a specific item, like a textile or like a mesh wall, or there's lots of different ones. It's kind of ridiculous the number of different factories that are out there creating all the different parts. Windows are one, but you're going to be responsible for setting up, testing, and then adjusting that factory equipment to make sure that the end product is perfect. And how does this apply to energy efficiency? Well, waste is not energy efficient, and by keeping these machines in top condition and your product output really refined, you're going to be reducing the energy use of that facility, and then ultimately the end building. So usually you're going to be monitoring the equipment, and this is going to require an associate's degree, again, from a community college or a junior college, and then you're going to be trained on those specific machines once you get the job. So if you like fixing things and working on machines, advanced manufacturing technician might be something you want to look into. Then there's engineering technicians. So this is kind of the next level of it. You're going to be taking a more holistic approach, and you're going to be solving technical problems on these machines, and you're going to use math, science, and engineering principles to do so. So it's going to be a little bit more narrow in focus and application specific than engineering. So you might be the expert in how a particular piece of equipment works, and you're going to be able to solve problems in the field. So typically, in my experience, the person who holds this job might work in one factory doing one particular thing, or they will travel a lot from factory to factory to maintain that piece of equipment wherever that equipment lies. So you're going to be reviewing plans and drawings to ensure compliance with regulations, making sure that things are working in the way that they're supposed to. Usually this job is going to require an associate's degree. You're going to want to be good at math and engineering, but maybe not as good as if you were to be going into the full engineer route. So there's lots of different options of careers, and that's just like the smallest of samplings. And I wish we had 10 hours to talk about all the different ways we can get into it, but we're going to put a pause on it there and kind of talk about Solar Decathlon with NREL that Jess is a part of, and kind of how I got involved. So I got here because of the Solar Decathlon, and this is a collegiate competition that challenges students to produce high performance, low carbon buildings that mitigate climate change. So basically the goal is to, for your group to build a tiny house, and then we take those tiny houses and we bring them up to Washington, D.C. and put them on the National Mall. It's part of a really big competition where you're judged on a bunch of different facets, how energy efficient it is, how sustainable your outcome is, and it was a really fun experience for me. And here's some pictures of my role. I was part of the University of Las Vegas School of Architecture's 2020 build competition. I was a assembly detailer and metal fabricator. I have experience welding, so I did all the metal parts on this. And so eventually, after you build these houses, then it gets moved to a location. Usually ours is put at the October 1st Memorial here in Las Vegas. But every group has a different outcome for their project. And so it was a really fun opportunity for the universities to pull in all the different fields. So we had engineers working on it, we had project managers, all learning how to do the job while in school. So it was a really fun experience. And the goal of it is to create the next generation of building professionals. So it gives us the opportunity to practice what we're learning. And I think that's a really important aspect of this competition. And it was a lot of fun, and I met a lot of great people. So things I want you guys to take away from this quick talk is that high performance buildings play a key role in achieving a sustainable future. And in fact, a huge role. 40% of energy usage comes from buildings. So any knockdown on that is great. You know, I like to recycle, but it wasn't enough for me. I need to have my job be a part of my goal for a sustainable future. And that's what led me here. But there's many paths to get involved in the sustainable construction industry, like arguably too many to count. The number of people that are involved is insane. And all of the presenters here come from different backgrounds and approaches to how we're going to tackle this problem of sustainability. So, and we're just a small sample. And then third, we have lots of different ways to attain highly lucrative positions doing what you love. The construction industry is very well paid, and there's lots of ways to get into it. So I don't want anyone to feel discouraged or think that you don't know what to do after high school, because there's lots of different ways to do this. And if a 4-year degree isn't your route, there's lots of others. And I'm really passionate about getting everyone excited about doing what they love, because it's there for you and it can be sustainable. So I think we're going to do questions at the end. So now I'm going to stop sharing and pass it over to Rory.
Thank you so much, Andrew. That was awesome. And I
Thank you.
think you glossed over welding, but I want to hear more about that later. But
Okay.
thanks so much. So we're going to kick it over to our solar team. So Andrew was kind of talking about energy jobs at large across the United States. Rory and Josh are going to speak specifically about their experience with solar in New York City and just how they got into the role and how you guys can kind of follow in their footsteps if that's something that feels right for you. So take it away, guys.
Hey, good afternoon, everybody. Excited to be here. My name is Rory Eblin. I'm the Solar Program Manager for New York City's Department of Education's Office of Energy and Sustainability. I'm joined here with my colleague here, Joshua Cano Jimenez. I'm going to pass it over to him to introduce himself.
Good afternoon, everyone. Thank you, Roy. We're very excited to be here. My name is Joshua Cano Jimenez. I am one of the solar project managers within the DOE Office of Energy and Sustainability, and we can't wait to share with you guys what we do.
I'm going to let Josh present, and then, we'll answer questions at the end. So, Josh, you want to take it off?
Sure. Kaylin, will you be sharing the screen or should I?
I got it, Josh. So I'll listen to you and I'll sift through the slides.
Can you share your screen, buddy, please? No, I can't see it, unfortunately. Right on. Thank you. Thank you. So as Rory mentioned a couple of minutes ago, we are the small but mighty New York City Solar Schools program team. We've completed installations on over 80 schools at this point. We've got about 200 schools in our active pipeline. So that includes design, vetting, etc. We currently have about 5 solar storage projects in design. 2 of them are actually in the Hunts Point neighborhood in the Bronx. And that's definitely an area that the city's looking to make more resilient due to its economic impact on the city. The vast majority of the food that we consume within the city starts or arrives there at the Hunts Point market, and then it makes its way to the rest of the city. At the moment, we're currently assessing a little over 200 schools for potential solar projects in the near future. And due to the overall size of the building portfolio within the DOE, at the moment we have about 80% of the city's overall solar installations within the DOE portfolio. Next slide, please. Awesome. So what are the criteria we use to assess schools for a potential solar panel installation project? So there are 3 different criteria that we take a look at. Number 1 is the overall size of the roof. So we look for large flat roofs that allow us to put as many panels as possible on the roof. That being said, we also look for any potential shading concerns that could be on site when we arrive to take a look at the roof. And that includes anything from adjacent buildings to adjacent trees. Additionally, we also take a look at the structural integrity of the building. We want to make sure that the building can withstand the pounds per square foot force or weight that we're going to be putting on the building's roof. And finally, we take a look at the overall age of the roof. So typically, a solar panel installation lasts 20 to 30 years. So we look to install our installations on roofs that are 10 years old or younger, just because it allows us to match up the overall life of the installation with the existing roof's warranty, just in case if anything happens throughout the life of the installation. Next slide, please. So the city's overall goal is 100 megawatts of solar on city-owned buildings by 2025. That being said, what are some of the benefits that come from installing solar on our school buildings and just on buildings overall within the city? Some of the benefits we see are money savings for the city in the form of credits, a reduction in air pollution, an increase in infrastructure resiliency, as we mentioned a couple of minutes ago, within projects such as the Hunts Point solar plus battery projects, and the opportunity to catalyze our education system. So the opportunity to catalyze solar within our education system. And the DOE at the moment, we've identified a capacity of 50 megawatts at the moment. So there's a lot of about 50 megawatts worth of solar within our DOE portfolio of buildings. So one of the awesome things of our program is that it comes, excuse me, it comes in tandem with the New York City Solar Schools Education Program, which includes professional learning workshops for teachers, access to real-time solar production data for our projects through through access to these remote monitoring systems that we use, such as Solar Energy, Solar One, actually. And it also includes, so back in the day, we used to install display monitors within main lobbies of our buildings. But at the moment, we're kind of moving away from that, and we're moving more towards installing banners with QR codes that teachers and students will be able to scan and take a look at the overall production of the system on the roof. The program also comes with the New York City Solar Career and Technical Education Program. To date, we've trained over 1,400 students and 28 teachers. We've disseminated professional certification opportunities for teachers throughout the DOE. We've paid solar CTE internships with installers. So that includes students being able to get on the roofs with some of our installers, such as Solar Energy Systems, to take part in the actual build of a system on a school roof. And it's a great way to expose our students to one of the fastest growing industries within the country at the moment. And this is the last slide for the presentation. So this slide basically gives an overview of what we do and some of the aspects of the program, some of the major aspects of the program. So as we can see, it begins with solar installations. Then we have the solar CTE internships with students on the roof. Then we take it to the classroom, and we have actual in-classroom lessons, solar CTE in-classroom lessons. And then finally, we have solar teacher professional development opportunities for teachers as well. So that concludes the presentation. Roy, do you want to go over some of your background, buddy? Do you want to share some of your background with the students?
Yeah, definitely. So again, I'm the solar program manager here at New York City's Department of Energy and Sustainability. I have been working in the solar industry for about 13 years. I started in 2010. Yeah, the solar industry in New York City was really booming at that time. There was a lot of incentives for residential homeowners and commercial building owners to take advantage of, and it really sparked the market here. And there was an opportunity. I started out as an installer and then stayed with the same company and kind of just worked my way into project management. I worked engineering and design, operations, inspections. I've done sales and marketing, so I was able to get a wide lens of experience in all the various opportunities. And we'll talk about this more as we go into it. There's so many opportunities in the solar industry. If you're interested in, business development, or if you're interested in marketing, if you're interested in using your hands in construction, and then if you're interested in, if you're an organized and, you enjoy puzzles and figuring stuff out, operations and engineering design is a great opportunity. So there's many avenues that you could take advantage of in this industry, and I'd highly advise. But yeah, I'm gonna stop sharing my screen. I think we can move forward to questions.
And Roy, you had an unconventional path to your role, right? You
Yes.
didn't go straight into college for solar. Can you speak a little bit to that?
Yeah, so like I was saying, I started in the solar industry in 2010. I didn't go to school. I didn't go to college right after high school. I thought I was too cool. I went into the construction field and quickly realized that it's super hard. And, I figured why use my body when I could use my brain? And I went back to school part-time as I was working, and it's very hard to do, but it's obtainable. But if you have the opportunity to knock school out when you're young, I highly advise that. But yeah, I started out doing construction. I had a friend that worked for a local municipality in the marine biology field, and I got a job building oyster reefs and clam beds and doing water quality surveys. And at the time, there was a connection with that municipality I was working with and a local solar company, and I was able to just kind of take advantage of the opportunities and advocate for myself, and interviewed and had some experience and got in. So fast forward to today, and I'm here in New York City installing solar on schools with Josh, and it's a wonderful job. There's tons of purpose around it, and I couldn't be happier.
Thank you so much, Rory and Josh. That was a great insight to the different avenues that you can take to get into any kind of clean energy sector job. To just give an update for New York City, 81% of the energy is used by municipal buildings. So that's us, right? And then we kind of, as a contrast, have 80% of the solar installation on our New York City school buildings. So we are kind of leading the charge in terms of having solar on buildings, and we're kind of modeling the behavior that we want to see other private industries do. So with that being said, thank you guys so much for your insights. We're going to open it up in the chat for you guys to drop some questions in. We have a question from Mr. Carlson that says, does it cost more to install solar panels or to use municipal power? And that's, I think, a little bit of a complicated answer, but we have some experts here to answer. So kick it over to you guys.
Yeah, I mean, I would say that it all comes down to what your current pull from the grid is. Like how much electrical use does your building require, right? And if you're a small building and you have tons of refrigerators and air conditioners, your demand is going to be obviously high, and you're going to have a high electrical bill. But it all comes down to site assessment, looking at your energy bills, seeing how much energy you consume over the year, and doing an analysis to figure out if it is cost effective for you to go down the solar pathway.
Yeah, so any questions you guys have with what the presentation was on, if you have questions about specific jobs or education paths, please drop them into the chat. I'm also going to drop a document that has some kind of already slugged questions that you guys can kind of freestyle and make your own if you're having a little bit of trouble kind of figuring out what it is that you want to ask. We have another question that says, what are the disadvantages of solar energy? Do the advantages of solar energy truly outweigh the disadvantages caused by the pollution created in the production and maintenance? Great question, Vinesh.
Yeah, that's a really good question. I just read an article, a study about cobalt mining in battery production, and analysis is into the impacts on the local resources, and how mining for some of these materials that are necessities for countries to reduce their carbon emissions. And I don't have a great answer in terms of solar, and I don't know if Andrew, if you know anything further in terms of the output of or the impacts on the environment in terms of the manufacturing. But I'd assume that with the awareness of sustainability, awareness of carbon reduction, that companies that are trying to compete in the market, they're also aware of their output and the impacts that their production and their operations have on the environment. So I'm assuming that that's happening, but yeah.
Yeah, it's somewhat complicated, and the technology is changing all the time, and I'm sure well, I guess you guys tie it directly into the grid, but I know the battery discussions are a complicated one that we're dealing with as far as the raw materials for it are somewhat complicated to extract. I know here in Nevada, we have a large lithium mine that is currently controversial, to say the least, and so I know that that's a big issue, and I know the technology on the solar panels themselves is improving, but we've kind of hit a threshold on their advancement, and we're waiting for that next big break that'll really send it over the edge. But what I've seen more and more is that we're using it anyway because it's cost effective for the end user. So it might be a little bit more expensive upfront, but over the life cycle of the project, you're going to be recouping your investment and more. So that's what I think why we're seeing this huge boom of solar investment over the private and public sectors.
I second Andrew's assessment. Lithium mining is definitely it's a dirty process. We all know that, and it's definitely at the forefront of what's going on in Chile as we speak because they have huge lithium mines in southern Chile. So I definitely second with what Andrew said. I think lithium mining would definitely be one of the bigger pain points.
Yeah, that's the article I read was about the high Andean Chile lithium reserves and the impacts on the environment and how to quantify that. And I think it's all this data, all these metrics that they're trying to obtain is still in the works, and I think we'll have a better picture of what it looks like soon. As this becomes an increased awareness around what you need to do to source those materials to reduce carbon in these technologies.
And I kind of want to jump in quickly for the students to talk about why we're talking about batteries, right? Because we're talking, we're talking about solar, but why are batteries important? Well, the sun's only shining during the day, but a good majority of our energy uses is at night when the lights are on. And so, in order to make solar our sole energy source, we need a way to maintain that energy over the full day. So we need to have battery storage capability to ensure that we have power whenever we need it. So that's why we're talking about batteries.
Awesome. Yeah. And thank you, Andrew. You just answered a question here that says, how does solar energy work when we have no sun for a long time? And that's where the batteries come in, right? The batteries store the excess from the solar panels. But in the long term, let's say for schools, Josh and Rory and Andrew, you seem pretty well versed in solar also. What would happen if it's a long stretch of not enough sun to charge those panels?
It's a good question. I'm trying to think of a scenario. I mean, what do we have? Like an asteroid hitting the Earth and
Well,
a dark blanket of ash?
how about the smog, Rory, from
Yeah.
the wildfires that came from Canada? Yeah, how about that?
Yeah. And that's a good point. That was a wild day. If anybody remembers that, that was interesting, and that was the first of its kind I think I've ever experienced. I've been living in New York and New York City for my whole life, so I do think, and what I've been told and what I've learned over the years, like on cloudy days, the solar panels still work, and I think in some cases the material or the water vapor inside clouds and stuff sometimes would, I guess, magnify the sun's intensity, and they may work even more efficiently. But yeah, I'm trying to think of a scenario. I think smog would be the best one, but I don't know. I'm gonna have to think about that.
Well, the best way for a robust renewable energy system is to have multiple sources, right? In the event that we run out of sun, then we have our wind systems, and we have our water or the wave energy reclamation systems, and there's lots of different ways we can handle it for when the wind stops blowing and the sun stops shining. We have other ways that we get our energy.
Awesome. Andrew, how does your welding experience tie in? Is there a clean energy forefront for that type of thing? How important is that in the future of creating sustainable energy?
Eating sustainable energy. Well, so I grew up in Missouri and I was working on farms, so that's where I first learned how to weld, and then I had the opportunity to do I was the only one who knew how to weld at my university, so it gave me the opportunity to practice some new techniques and get better at it. As far as the role it plays in sustainable energy, I mean, I guess it depends on what it is that you're constructing. Yeah, that's a tough one.
I'm just trying to tie it back and say I'm very interested in that as a career path. I think that this doesn't necessarily,
Oh,
it's
well,
not a Venn diagram quite yet, but it is very
sure.
interesting
I mean,
CTE path.
I'm sure there's welders that are involved in the solar panel construction that surely can't all be done by the robotic manufacturing systems, can they, Rory? Or, I don't know if you guys are involved in manufacturing of the panels or.
No, we're not involved in the manufacturing aspect. We're more on the operations construction side.
Sure.
Hmm.
Yeah, and that's usually going to be a bolt down system or something of the like, but there's definitely roles in fabrication facilities where you're going to be doing welding, and that there's opportunities out there. I don't necessarily know exactly. I like it.
Yeah, yeah, it's
I
interesting.
think it's a really handy tool in your construction tool chest. But as far as how you apply it is really where the sustainability comes in.
Right. And so we have a question from Aiden. How do you see the future of clean energy evolving? And what jobs and roles are necessary or will be in high demand? That's a great question.
Yeah, I mean, I think now that we're getting better at creating clean energy more efficiently, there's for the intermediate future, it's going to be about creating clean energy is the primary job source. So the solar farms, the solar on the roof, the wind farms, the water systems. There's numerous opportunities out there, and the what we typically see is that when things are financially viable, such that they generate their saving the owner money, then they start getting implemented. And right now, it makes financial sense to start developing all these systems. So I think for the intermediate term, it's going to be creating energy. And then after that, we're going to say, all right, we have plenty of energy. Let's reduce how much energy we actually need to be creating on this sustainable side. And so we're going to be really tightening down our building envelopes and our building systems and reducing our energy in the buildings. They're going to be happening in tandem, but that's kind of how I see it happening.
I also see the future of the battery industry in New York City kind of opening the door for an opportunity in terms of operations and maintenance for the lifespan of the system. Again, it's so new in New York City. There's a lot of opportunity because of the regulatory rules in place from the fire department in New York and what is required to actually operate and maintain the system throughout its lifespan. And there's not a lot of individuals out here that are specialized in that stuff. So, if you are interested in battery technology, I think in the next few years, you're going to see a lot of opportunities in terms of just, fixing these systems when they fail or if they go down. And I know that there are individuals out there that charge a lot of money to perform this right now because it is so new, because the demand is high, because the market is kind of about to take off. But yeah, and I saw that too with solar when I started doing solar in New York State. We didn't really think about the down the road in terms of maintaining the systems and the issues that come up eventually. And then eventually the companies I was working for, we formed post installation departments, the individuals that are specifically responding to requests from building owners to come out and fix certain aspects of it. So I see the whole operations and maintenance industry as an opportunity.
Thank you for that. That's great intel. This is a great question from Rosales. What is the estimated time frame for solar panels being installed in apartment buildings in New York City?
It's a good question. Again, not every building in New York City can receive it. It all comes down to when you analyze and assess the building, is there enough space? Shading's a big concern too. Some of our flat roofs on New York City schools, the roof sits within like these parapet walls that are raised above the roof grade, and that poses some shading concerns. So it really comes down to understanding the solar readiness of each building in New York City, residential, commercial, municipality buildings, institutional buildings, everything, and figuring out where you can actually install it. So I don't have a good answer, but I do think with our goals set and trying to hit 100 megawatts of solar and become carbon neutral by 2050, I think we're going to do a lot.
Also, to chime in on today's Climate Action Day, right? And it's based around energy. And you all, as students and consumers of energy in New York City, play a huge role in what happens next in the way that you contact people who make those decisions. So you guys have a large hand in how these things can either be ramped up or rolled back. So if you are interested in advocating for clean energy, there are ways for you to do that. And that is something that we highly encourage you to do, right? We want to be going carbon neutral, which means we're not producing carbon with our energy intake. So there are a lot of ways that we can do that. And I love that Andrew said that there will be multiple ways for us to do that. We won't be relying just on solar to be providing energy or just on some other things that we may start incorporating in New York City. And we're going to take this question from Joshua, and then we'll have one final question. Joshua says, I'm in 9th grade. How can I get a job like this after graduating high school? And what are the requirements for these jobs? He's currently a student at the Brooklyn School of Career Development.
Yeah, it's a good question. I think I would first ask myself what I'm most interested in. Or is it, do you want to be on roofs? Do you want to learn the actual electrical engineering around it? Do you want that real hands-on experience of, starting and completing a project? If you're trying to be a solar installer, and you're going to go to college, I would probably try to go down an electrical engineering path and obtain a degree in that, so you understand how the system works on paper and then also in the real world environment. Again, and then there's other aspects too of the industry. If you're into business development, I would go down a business administration degree to understand how businesses work, how you can make money and become profitable as a business and understand the inner workings that way. If you're somebody that wants to kind of stick by yourself and just do your work and go home, engineering and design is a good one too, because you're really just spending time on the computer, utilizing the software to create the drawings and generate the documents that are needed to obtain building permits and stuff like that. There's so many different opportunities out there with solar.
What's their route for getting involved in your paid internship program?
So one of the requirements is they have to have taken part in our solar CTE training that we.
It's only available at certain schools, right?
Yeah, it's only available at CTE high schools, career technical education high schools in New York City. And again, that's a solar education opportunity to learn everything about solar. And then if you're interested, you can then follow the pathway to the internship.
And then the final question I think we ended on our last chat with is, how does a school start the process of getting solar panels installed on their own schools?
Yeah, I would definitely suggest emailing Josh and myself. We have an email. It's New York NYC Solar Schools at schools.nyc.gov. And, I would just send an email introducing yourself, say, hey, I'm a student or I'm a teacher at, so-and-so school. We're interested in solar, and Josh and I will look at it. We'll take a look at the school. We'll run an assessment analysis on it to figure out if it's fitting within the parameters that we've mentioned previously in our slides. And then what we could do is, if it's a great candidate, we can allocate it to an upcoming construction portfolio.
That's awesome. Thank you so much. And we will be following up. We'll send you guys in the follow-up email a school building data information document that you can check to see if your school already has solar panels, so that you may be getting new information that you didn't know was true before. So that is going to conclude our Clean Energy Career Talk. So thank you all for coming. We are so happy that you were interested in these types of career paths and that you took the time to visit us today. And we hope that you have a really wonderful rest of your Climate Action Day. Thank you to Andrew, Josh, and Rory. This was really informative and really wonderful. I wish there were talks like this when I was in high school. Who knew where I would have ended up, but I'm happy to be here. But it was great to have you all. Thank you all for coming, and I hope you found this informative, and we hope to see you on some roofs in the future, installing some solar panels.
Thank you.
Thank you so much.
everyone.
Thanks,
Take care.
everyone.
Thanks, Andrew. Stay cool out there in Nevada. I don't know how you guys do it.
Thanks, feeling it bad. Yeah, it's 70 outside right now, so it's
Not
pretty
too bad.
okay.
That's pretty temperature.
I mean, it is December, so I mean,
That's true. That's fair. It's getting much colder here. So, but
yeah.
also thank you so much. This was great. Thank you.
No, thank you. This was a blast. Appreciate it.
Take
Thanks,
care.
Andrew.
Happy holidays.
See you guys.
Bye-bye.
Bye.